So, now let us see apparent depth for normal incidence. We have observed that if we look inside a water where there is a coin, and if we look above it, from above it, the ray goes like this, and again here the ray goes like this, and this is our eye. So, we find that the object is formed here. So, the object shifts upward. This is what is apparent depth for normal incidence. So, if the bottom of an aquarium or anything is seen to be raised above when we see normally, so this is called apparent shift for normal incidence. Now, here we are going to calculate that how much is this shift. Where is the new location of I? If this distance is h, then this location we will see that h dash is equal to h by mu. Let us calculate this. Now, suppose this is the surface which separates some two medias. Here suppose this is water, and let us assume that this is water. We won't draw so many lines. So, suppose we have an object O here, this height is h, and let us consider a paraxial ray. This is an exaggerated diagram, so which further bends like this, and we see here. So, first of all we have to understand the exaggeration, and thus you see image is formed. You see here this angle is very small, of the order of less than 1 degree, of the order of 1 degree. So, you see just exaggeration. So, you just imagine if this is the order of 1 degree, then this eye is actually not placed here, this eye will be placed here, normal incidence. So, I have no choice, I can't draw 1 degree, so I have to exaggerate my diagram. So, do not think that you are seeing obliquely, you are seeing the object normally. So, let this point be called A and this point be called B, and let this distance be denoted by D and this distance be denoted by D dash. Depth D, what depth it appears to us is this. Now, here we will apply our Snell's law. This angle will be I and this will be angle of refraction. Let this medium has a refractive index mu and here 1. So, applying Snell's law at the refracting surface. So, we have mu times sin I, mu times sin I is equal to, here refractive index is 1 times sin R. Now, for paraxial rays in bracket, since the view is normal, means we are seeing it normal perpendicularly to the surface, this sin theta will be written as tan theta will be written as theta. So, mu sin I means tan I is AB by BO is equal to 1 times sin R. This angle is R, so will be this angle R, so will be this angle R, and this is I. So, sin I is sin I is tan I, AB by BO, and sin I is equal to tan R, that is AB by BI. This AB cancels, mu by BO is D, and 1 by D dash implies D dash is equal to D by mu. So, the image will be formed at d by mu distance, that is, it is raised up. The apparent shift becomes the apparent shift in the image becomes delta is equal to, what is the distance it goes above, is d minus d dash, that is d minus d by mu, that is delta is equal to d 1 minus 1 by mu. So, this is the apparent shift for normal incidence by this refracting surface. Now, let us see, if we are really seeing at some angle, if there is an oblique angle of view, then how the object O will appear to be and where will it will appear. That is apparent depth for oblique incidence. Next topic. Now, you see here apparent depth for oblique incidence. This is my object at a distance d from here. Now, if I see normally, now the image is formed at a distance d by mu. This distance is d by mu. Now, as my angle of view changes from 90 degree to less, if I am seeing from this, if my view is like this, then previously you see the image is I1, now the image is I2. It goes further above it and it is displaced in the direction of the view, that is the I. So, the image is not formed on the normal line. This image is not, previously the image was formed here, this is the normal line, and so the image is not formed here, it is displaced in this direction I2. Next, when I further move here, the image further goes, so it is further shifted above as well as this way. So, the curve along which the image will shift like this, this will be a curve. As we go on, the image will go above and it will shift. This is how the apparent depth for oblique incidence will be there. In next few classes, after few classes, I will mathematically calculate if the angle of here view is theta, what is the coordinates of the image here, but presently we are not going to do that. So, this is for oblique incidence. Now, next topic is that if here this is water or glass and this is air. Now, if we are viewing from the water, then how the object, if object placed this side, how it will appear, that is apparent height for normal incidence and oblique incidence.